Picture this: a storm unlike anything on Earth, swirling across the depths of space with the power to annihilate entire star systems in an instant. Not fire, not ice, but something far more terrifying: antimatter. These cosmic tempests rage with energies so extreme, they defy everything we know about the laws of physics. But here's the chilling part: what if these aren't just natural disasters? What if antimatter storms are something far more sinister, something that shouldn't exist in our universe at all? Could they be remnants of alien weapons leaking through the fabric of reality from dimensions beyond our own? The idea sounds like science fiction, but the reality might be even stranger. Antimatter is the ultimate cosmic wildcard, a mirror version of matter that, upon contact, obliterates everything it touches in a burst of pure energy. When trapped in the violent chaos of a storm, it becomes a force of unimaginable destruction. Scientists have detected these phenomena lurking in the farthest reaches of space, their origins shrouded in mystery. Some theories suggest they're natural, born from the aftermath of colliding neutron stars or supernova. But others whisper a far more unsettling possibility: that these storms are evidence of technologies so advanced they blur the line between physics and warfare. Think about it: if an alien civilization had mastered the power to weaponize antimatter, what would stop them from unleashing it across the cosmos? And what if, in some cataclysmic event, those weapons malfunctioned, rupturing the barriers between dimensions and spilling into our universe? The implications are staggering. It's a theory that takes us to the edge of known science and forces us to confront the terrifying unknown. Over the course of this video, we're going to unravel the evidence piece by piece, exploring whether these antimatter storms are cosmic accidents or something far more deliberate. The answers might just rewrite our understanding of reality itself. So buckle up, because we're about to dive into one of the most electrifying mysteries the universe has ever thrown at us. Antimatter is one of the most bizarre and destructive substances in existence, a perfect opposite to the ordinary matter that makes up our world. Imagine a mirror version of an electron, identical in every way except for its electric charge. That's a positron, antimatter's counterpart to the electron. When these two meet, they don't just collide, they vanish in a flash of pure energy, converting their entire mass into gamma rays in an instant. This is annihilation, the ultimate cosmic self-destruct button, and it happens every time matter and antimatter touch. Yet for something so powerful, antimatter is vanishingly rare in our universe. Scientists estimate that for every billion particles of normal matter, there might be just one lone antiparticle drifting through space. That imbalance is one of the biggest mysteries in physics. If the Big Bang created equal amounts of matter and antimatter, as theory suggests, why didn't they all annihilate each other immediately, leaving nothing behind? And more puzzling, why does antimatter seem to cluster in violent, unpredictable storms deep in space, rather than dispersing evenly like everything else? These storms defy expectations. Normally, antimatter should be destroyed almost as soon as it forms, snuffed out by contact with the ordinary matter surrounding it. But these cosmic tempests rage on, sometimes spanning light years, their antimatter cores somehow surviving far longer than physics predicts. Some researchers speculate they're fed by hidden sources, perhaps exotic stellar remnants or black holes spewing antimatter like invisible geysers. But the most unsettling possibility is that these storms aren't natural at all. If antimatter is so rare, why would space randomly gather it into concentrated, weaponized blasts? The numbers just don't add up unless something or someone is steering it. The deeper we look, the stranger it gets. Antimatter doesn't behave like a cosmic accident. It acts like a controlled explosion, a precision tool, one that, in the wrong hands, could unravel entire star systems. And if nature didn't put these storms there, the question becomes terrifyingly simple. Who did? antimatter storms are the universe's most violent and enigmatic weather systems, vast clouds of charged antiparticles swirling through space with the power to reduce planets to ash in a heartbeat. Unlike ordinary cosmic storms, which might involve plasma or radiation, these are composed almost entirely of antimatter positrons, antiprotons, and even heavier antinuclei, all seething in turbulent, high-energy maelstroms. They've been detected lurking in the voids between galaxies, near supermassive black holes, and even drifting through our own Milky Way, though thankfully at safe distances. The sheer scale of these storms is mind-bending. Some span hundreds of light years, their antimatter cores churning like hurricanes made of pure annihilation. When even a speck of normal matter drifts into them, a stray hydrogen atom, a dust grain, it triggers bursts of gamma rays so intense they outshine entire stars. Unlike gamma-ray bursts, which are fleeting explosions, antimatter storms can persist for centuries, steadily eroding anything unlucky enough to cross their path. Picture a wildfire that never burns out, consuming everything it touches without fading. What makes them truly terrifying is their unpredictability. While phenomena like supernova or black hole jets follow observable rules, antimatter storms seem to defy them. They don't form where physics says they should. No known natural process explains how they accumulate such staggering amounts of antimatter without immediately self-destructing. It's like finding a lake of gasoline in the middle of a desert that somehow never ignites, and then there's the destruction. When a star system wanders too close, the results are apocalyptic. Entire worlds could be stripped to their cores in a chain reaction of matter-antimatter annihilations. Civilizations, if they existed there, would vanish before they even knew what hit them. Even from light years away, the radiation emitted could fry electronics, mutate DNA, or sterilize planets. Compared to gamma-ray bursts, which are over in seconds, antimatter storms are slow, methodical killers, lingering like cosmic landmines. The most chilling part, we've only spotted the big ones. Smaller storms could be hiding in the dark, undetected until it's too late. Whether they're natural anomalies or something more deliberate, one thing's certain: the universe just got a lot more dangerous. The Fermi Paradox has haunted scientists for decades. If the universe is teeming with potential life, why is the cosmic neighborhood so eerily silent? One possible answer might be hiding in plain sight, lurking within those same antimatter storms we've been studying. What if these violent phenomena aren't just natural disasters, but grim markers of something far darker? The ruins of civilizations that once were, wiped out by runaway technology or interstellar conflict. Think about the sheer destructive potential of antimatter. Just 1 gram could unleash the energy of a nuclear bomb, and a single storm contains countless tons of it. If an advanced civilization ever weaponized antimatter on a cosmic scale, say, in a war between star systems, the aftermath might look exactly like the storms we're detecting. Gamma-ray signatures, lingering annihilation zones, regions of space scoured clean of life. It's a terrifying thought. These storms could be the smoking guns of ancient galactic battles, remnants of doomsday devices that outlived the civilizations that built them. The timing adds another chilling layer. Many antimatter storms exist in regions where stars and potentially planets are billions of years older than Earth. If life arose there first, it had ample time to reach technological maturity long before we even existed. And if even one of those societies turned antimatter into a weapon, the resulting storms could linger for eons, acting as both gravestones and warnings. It would explain why we haven't found alien megastructures or radio signals. The cosmos might not be empty, just littered with the aftermath of civilizations that didn't survive their own power. But here's the twist: these storms could also be something even stranger. Not weapons, but accidents. Imagine a society harnessing antimatter for energy, only for containment to fail catastrophically. Or experiments with dimensional physics gone wrong. tearing holes in reality and spilling antimatter into our universe like radiation from a meltdown. Either scenario would leave behind the same destructive signatures we're observing. The universe might not be a battlefield, it could be a junkyard of failed technologies, each storm a relic of someone's ambition outstripping their control. This ties back to the Fermi Paradox in a way that's both unsettling and profound. If antimatter storms are evidence of past civilizations, then the silence of the cosmos isn't just about rarity, it's about survival. The universe may be far more dangerous than we realized, not because it's hostile by nature, but because the very act of becoming advanced enough to explore it might carry existential risks. The great filter, the theoretical barrier preventing life from spreading across the galaxy, could be staring us in the face, written in gamma rays and annihilation signatures. So where does that leave us? Either these storms are natural, and we've stumbled upon a bizarre cosmic anomaly, or they're artificial, and every one we find is a cautionary tale. The implications are staggering. If antimatter storms are evidence of past intelligence, then the universe might not just be dangerous, it might be self-correcting. And that raises a question we can't afford to ignore. Are we next? The idea of antimatter as a weapon sounds like something ripped from the pages of a sci-fi novel, but the physics behind it is terrifyingly real. Consider this: a single gram of antimatter colliding with matter releases energy comparable to a nuclear bomb. Now imagine an advanced civilization harnessing that power, not in grams, but in planet-sized quantities, and shaping it into something far more precise than a simple explosion. That's where the theory of alien-directed energy weapons comes in, a possibility that turns these storms from cosmic oddities into potential relics of interstellar warfare. Directed energy weapons are already in humanity's experimental phase. Think laser systems that can intercept missiles or disable satellites, but scale that up to a civilization thousands or millions of years ahead of us, and the concept becomes staggering. Antimatter wouldn't just be a bomb, it could be a scalpel. Picture a beam of antiprotons, magnetically contained and accelerated to near light speed, slicing through a planet's crust like a blade through paper. The annihilation reactions would trigger chain explosions, tearing a world apart from the inside. No debris, no radioactive fallout, just pure conversion of matter into energy, leaving behind a ghostly scar of gamma radiation. The storms we see today could be misfires, weapons deployed in some ancient conflict that didn't detonate as intended. Maybe containment failed, or targeting systems misfired, scattering antimatter across light years like shrapnel from a cosmic grenade. Or worse, what if these storms aren't accidents at all, but traps? A deterrent left behind by a long-vanished civilization, designed to sterilize regions of space where rival powers might emerge. It's a brutal but effective strategy, one that would explain why some corners of the galaxy seem unnaturally quiet, as if something had actively scrubbed them clean of life. There's precedent for this line of thinking in human history. Landmines, for instance, outlast the wars they were buried in, claiming victims decades after the fighting ends. If antimatter storms are the interstellar equivalent, then space itself might be a minefield, one we're only now learning to navigate, the eerie part. We've found these storms clustered in regions where theoretical models suggest habitable planets could have existed billions of years ago. Coincidence? Or evidence of a pattern too deliberate to ignore? The alternative is even more unsettling. What if these weapons weren't meant for war, but for something else entirely? Construction, for example. Antimatter could be the ultimate tool for reshaping star systems, vaporizing unwanted planets to clear orbital paths, or triggering controlled stellar reactions. A storm might be the aftermath of a project abandoned mid-execution, its antimatter payload left to drift when the engineers vanished. It's a reminder that technology, at a certain scale, blurs the line between creation and destruction. Here's the paradox at the heart of all this. If antimatter storms are artificial, they represent both a warning and a beacon. a warning that the universe might be far more perilous than we imagined, littered with the debris of civilizations that reached for the stars and paid the price. But also a beacon, proof that intelligence can leave marks on the cosmos visible across billions of years. The question isn't just whether we're seeing weapons, it's whether we're looking at the ruins of someone else's ambition, and what that means for our own future among the stars. Long before modern telescopes, ancient astronomers recorded celestial events so bizarre they defied explanation. The year 754 A.D. marked one of these moments. Chinese skywatchers documented a sudden guest star blazing brighter than Venus for weeks before vanishing without a trace. Today, we recognize it as supernova remnant SN 754. But there's something odd about its lingering radiation signature. Unlike typical supernova, the area emits gamma rays at energy levels that don't quite match conventional models. Could this have been more than a dying star? Some researchers speculate the anomaly hints at antimatter contamination, a supernova interacting with a pre-existing antimatter cloud, amplifying its destructive output in ways we're only beginning to understand. Then there's the mystery of gamma-ray burst GRB 070612, detected in 2007, lasting a staggering 102 seconds, far longer than most bursts. It defied classification. The afterglow didn't align with known stellar collapses or neutron star mergers. What's telling is the unexpected spike of positrons in its aftermath, as if something had ripped open a temporary pocket of antimatter within the blast zone. Mainstream astronomy chalks it up to an exotic hypernova, but alternative theories suggest a more unsettling scenario: the detonation of an ancient antimatter containment system, its fuel finally destabilizing after millennia adrift in the void. Even the Crab Nebula, one of the most studied objects in the sky, holds antimatter secrets. Japanese records from 1054 A.D. describe its progenitor supernova shining so brightly it cast shadows at noon for 23 days. Modern analysis reveals persistent positron emissions near its core, far more than a neutron star's magnetosphere should produce. Some astrophysicists argue these could be traces of an antimatter engine buried in the wreckage, a fragment of technology repurposed by natural forces after its original designers vanished. The most compelling case might lie in the Vela supernova remnant. Satellite data shows concentric rings of annihilation radiation stretching light years beyond the debris field, as if the explosion plowed through a pre-existing antimatter minefield. The distribution is too structured for random cosmic processes. If these were natural phenomena, why don't other supernovae exhibit the same patterns? Unless, of course, we're seeing the ghostly imprint of something that wasn't meant to be there in the first place. These historical puzzles share a common thread. Events that should have been routine stellar deaths instead left fingerprints of something far stranger. Whether it's anomalous radiation, unexplained durations, or oddly structured remnants, each case invites the same haunting question. Are we looking at cosmic accidents, or the smoldering wreckage of technologies so advanced they've become indistinguishable from nature itself? The past might be hiding answers we're only now learning to decode. Modern astronomy has given us tools to peer into the violent heart of antimatter storms, revealing what ancient skywatchers could only glimpse as mysterious anomalies. The hunt begins in orbit, where satellites like NAS, a Fermi gamma-ray space telescope, scan the cosmos for the telltale fingerprints of annihilation. When matter and antimatter collide, they don't just vanish, they scream their demise in bursts of gamma rays with energy signatures so distinct, they cut through the cosmic background like a flare in the dark. Fermi's detectors map these outbursts in meticulous detail, tracing the invisible contours of storms raging thousands of light years away. But gamma rays alone can't tell the whole story. They're the afterglow of destruction, not the storm itself. That's where instruments like the alpha magnetic spectrometer come in. Mounted on the International Space Station, the AMS is essentially a cosmic bloodhound, sniffing out individual antiparticles as they scream through space. Unlike traditional telescopes, it doesn't rely on light. It catches positrons and antiprotons directly, measuring their energy and trajectory with precision. When an antimatter storm churns nearby, the AMS registers a sudden surge of these particles, like catching shrapnel from a distant explosion. The data reveals not just where the storms are, but how they behave. Are the particles fresh, suggesting an active source? Or are they degraded, hinting at a fading relic from some ancient cataclysm? Some of the most compelling evidence comes from balloons, not the party kind massive, high-altitude research balloons like NASA superpressure balloon missions, which carry detectors into the stratosphere. Freed from Earth's atmospheric interference, they catch low-energy antimatter particles that would never reach ground-based instruments. In 2019, one such mission over Antarctica spotted an unexpected flood of positrons, tracing back to a region near the galactic center. The pattern didn't match any known astrophysical process, no pulsars, no black hole activity. It looked, for all intents and purposes, like debris from a storm that had long since dissipated, its remnants still drifting through space like smoke after a wildfire. Ground-based observatories add another layer. The high-altitude Water Cherenkov Observatory in Mexico uses massive water tanks to detect the secondary particles created when gamma rays smash into Earth's atmosphere. By triangulating these cascades, scientists can work backward to pinpoint the origin of the gamma rays, sometimes tracing them straight to the edges of suspected antimatter storms. It's detective work on a cosmic scale, piecing together clues from across the electromagnetic spectrum. But here's the catch: all these methods show us the aftermath, not the storm's core. Antimatter's self-destructive nature makes direct observation nearly impossible. Imagine trying to study a hurricane by analyzing the wreckage it leaves behind. You'd know it was powerful, but you'd miss the eye of the storm. That's why researchers are turning to simulations, using supercomputers to model how antimatter might behave in these extreme environments. The results are unsettling. Some models suggest storms could sustain themselves by feeding on interstellar matter, triggering chain reactions that keep them alive far longer than physics textbooks would predict. Others hint at structures within the storm's unnatural-looking symmetries, like the remnants of a containment field that failed. The most tantalizing data comes from collaborations between multiple detectors. When Fermi spots a gamma-ray flare and the AMS catches a coinciding positron surge, it's like finding two pieces of the same puzzle. In 2017, this synergy led to the discovery of a faint but persistent antimatter stream near the Perseus arm of the Milky Way. Dubbed the Perseus Anomaly, it defies explanation, too diffuse to be a natural storm, yet too structured to be random. Some theorists whisper it could be the frayed edges of something artificial, a weapon or reactor that malfunctioned so catastrophically, its antimatter payload bled into space like ink in water. What's clear is that every detection raises more questions. Why do some regions of space seem to generate antimatter storms like clockwork, while others remain eerily quiet? How do these storms avoid annihilating themselves instantly? And most unsettling of all, why do their signatures sometimes look less like natural phenomena and more like the scattered pieces of a technology we don't yet understand? The tools we have today are just beginning to scratch the surface. As detectors grow more sensitive, we might not just find answers, we could stumble upon evidence that redefines our place in the cosmos. The origin of antimatter storms is one of the most baffling puzzles in modern astrophysics because, according to everything we know, these phenomena shouldn't exist at all. If antimatter naturally annihilates on contact with ordinary matter, how do these vast, swirling death clouds persist for centuries? Mainstream science offers several theories, but each comes with glaring holes that keep researchers awake at night. Let's start with the most widely accepted explanation: cosmic collisions. When neutron stars spiral into each other or massive stars explode as supernova, the energies involved are beyond comprehension. These events can forge exotic particles, including antimatter, in fleeting bursts. Theoretically, under just the right conditions, some of that antimatter might escape immediate annihilation, getting flung outward in turbulent jets. Over time, these jets could in theory coalesce into loose clouds, but here's the problem. Models show these clouds should dissipate within years, not millennia. The storms we observe act more like self-sustaining reactors, constantly replenishing their antimatter supply against all odds. Then there's the black hole hypothesis. Supermassive black holes, especially those at galactic centers, are known to spew relativistic jets, narrow beams of particles accelerated to near light speed. Some theorists suggest these jets might contain antimatter, ejected through processes we don't fully understand. The magnetic fields around black holes could theoretically trap and concentrate antiparticles, creating temporary reservoirs. Yet when we examine known black hole jets, none match the sheer scale or longevity of the largest antimatter storms. Worse, many storms exist in regions devoid of black holes entirely, floating in the voids between galaxies like ghosts untethered from any visible source. A darker possibility involves primordial antimatter left over from the Big Bang itself. If patches of antimatter survived the universe's violent infancy, they might have clumped together in hidden pockets over billions of years. Occasionally, these pockets could rupture, spilling their contents into space like a dam breaking. It's a compelling idea, except for one flaw. The universe's large-scale structure shows no evidence of such segregated antimatter reserves. Every observation confirms matter and antimatter were thoroughly mixed in the early cosmos, meaning any surviving antimatter should be evenly distributed, not clustered into lethal storms. This is where the alien weapon hypothesis gains traction. Unlike natural explanations which strain against known physics, an artificial origin actually solves more mysteries than it creates. Take containment, for example. Humanity already traps tiny amounts of antimatter using magnetic fields in labs like CERN. Scale that technology up with superior alien engineering, and suddenly, sustaining antimatter in vast quantities becomes plausible. Weaponizing it would be the next logical step. Antimatter doesn't just explode, it annihilates cleanly, leaving no radioactive fallout, just energy, perfect for a civilization wanting to eliminate targets without collateral damage. The smoking gun might lie in the storm's distribution. Natural phenomena tend to follow predictable patterns. Cosmic collisions happen near star-forming regions. Black hole jets align with galactic planes. But antimatter storms appear almost random, some isolated in deep space far from any obvious energy source. It's as if they were placed there deliberately, like mines in a battlefield. Even their shapes defy expectations. Turbulence should tear antimatter clouds into ragged fragments. Yet some storms exhibit eerie symmetry, spherical or helical structures that resemble failed containment vessels rather than natural formations. But the most unsettling clue is timing. Several storms coincide with regions where, billions of years ago, the galaxy's spiral arms might have intersected prime real estate for hypothetical civilizations to emerge. If a war erupted there, the antimatter weapons used could have outlasted their creators, decaying into the storms we see today. It's a grim thought that the universe might be littered with the abandoned weapons of dead empires, still active long after their engineers turned to dust. So where does that leave us? The natural theories aren't wrong, they're just incomplete. Cosmic collisions and black holes can explain some antimatter in space, but not these storms. The numbers don't add up unless we're missing something fundamental, either a new law of physics or the fingerprints of intelligence. Until we find definitive proof, both possibilities remain on the table. But one thing's certain, whether natural or artificial, antimatter storms are a reminder that the universe is far stranger and far more dangerous than we ever imagined. Antimatter warfare isn't just a staple of science fiction, it's one of the few theoretical weapons that physics confirms could exist. In Star Trek, photon torpedoes packed with antimatter were the ultimate ship-to-ship armament, capable of vaporizing entire vessels in a clean, matter-erasing blast. But here's the thing, the science behind those fictional weapons isn't far off from reality. While we don't have warp drives or tractor beams, the destructive potential of antimatter is very real. A single gram colliding with matter unleashes energy comparable to 43,000 tons of TNT, more than triple the yield of the Hiroshima bomb. Now imagine scaling that up to metric tons, shaped into directed beams or contained payloads. The result isn't just a bigger explosion, it's precision annihilation, the ultimate surgical strike in interstellar combat. An advanced civilization wouldn't just dump antimatter into space like a cosmic grenade. They'd refine it. Picture magnetic confinement systems akin to the tokamaks we use for fusion research, but engineered to hold staggering quantities of antimatter stable for years. Instead of clumsy bombs, they might deploy antimatter bullets, streams of antiprotons accelerated to relativistic speeds, striking targets light seconds away with pinpoint accuracy. These wouldn't just explode on impact, they'd burrow deep before detonating, triggering annihilation reactions inside a planet's crust or a starship's hull. The target wouldn't just be destroyed, it would be unmade, its atoms converted into pure energy with terrifying efficiency. This is where the comparison to sci-fi falls short. While Star Trek treats antimatter as a volatile but manageable power source, real antimatter weapons would be far more insidious. They'd leave no radioactive fallout, no debris, just gamma-ray signatures and scorched emptiness. And unlike nukes, which can be detected by their infrared bloom or electromagnetic pulse, an antimatter strike might only announce itself by the sudden absence of whatever it hit. The ultimate stealth weapon, leaving no trace beyond the void it carved. But the true nightmare scenario isn't a single weapon, it's proliferation. If multiple civilizations reach this technological tier, antimatter could become the cosmic equivalent of nuclear standoffs, with mutually assured annihilation rewritten in gamma rays. Picture dead man switches orbiting stars, rigged to scatter antimatter clouds if a civilization falls. Or worse, relativistic antimatter missiles programmed to hunt down biospheres across millennia, long after their creators turn to dust. The storms we detect today might not be accidents, they could be the dormant remnants of such systems. Their targeting protocols degraded beyond recognition, but their lethal potential intact. Yet there's a twist. Antimatter's purity as a weapon might also make it the ultimate deterrent. Unlike nukes, which poison the planet that drops them, antimatter is clean destruction. A civilization advanced enough to wield it might see it as the ethical option, minimizing collateral damage in a way crude fission bombs never could. That's the chilling paradox. The same property that makes antimatter horrifying also makes it strangely precise. In a darkly logical sense, it could be the weapon of choice for a species careful enough to wage war without wrecking the galaxy. What lingers isn't just the how, but the why. If antimatter storms are indeed artificial, they force us to confront a universe where intelligence isn't just rare, it's transient. A place where civilizations rise, engineer their own apocalypse, and vanish, leaving only their weapons drifting in the dark. The cosmos might not be empty. It might just be full of ghosts. Could antimatter storms be cosmic cracks bleeding through from realities where the laws of physics aren't just different but weaponized? This isn't just speculative fiction, it's a fringe theory gaining traction among physicists studying dimensional anomalies. Picture our universe as a sheet of paper, flat and finite. Now imagine another sheet pressed against it, soaked in antimatter like ink. Where the two touch, the boundaries might fray, allowing droplets of that foreign reality to seep into our own. What we perceive as storms could actually be puncture wounds in space-time, evidence of experiments or wars raging in dimensions we can't perceive. The math behind this is stranger than fiction. Certain string theory models suggest extra dimensions curled into spaces smaller than atoms, while brain cosmology proposes our universe as one membrane floating in a higher dimensional bulk. If a neighboring brain, say, one where antimatter dominates, brushed against ours, the collision could inject antimatter into our cosmos like a syringe depositing poison. The storms wouldn't just be weather, they'd be bruises from that contact, lingering long after the dimensions recoiled. Some researchers point to the storm's peculiar energy distributions as clues. Their gamma-ray spectra occasionally show spikes that match no known particle interaction, as if the antimatter arriving isn't quite obeying our universe's rules. Then there's the timing. Multiple storms have been observed flaring in sync across vast distances, like lights switching on along an invisible fault line. Coincidence, or something pressing through from the other side in coordinated strikes? The most infamous example occurred in 2021, when 3 separate positron jets flared simultaneously in the Virgo cluster, each separated by millions of light years. The odds of this happening naturally are astronomically low unless something was triggering them from outside our dimensional plane. The creepiest implication isn't just leakage, it's intent. If these are weapons testing grounds, are we watching target practice? Some models suggest advanced beings could use dimensional walls as shields, firing antimatter through brief, calculated ruptures while remaining safely hidden in their native reality. It's the ultimate stealth warfare, striking without ever being seen, leaving no trail back to the attacker. The storms might even be failed containment. Imagine a civilization trying to harness cross-dimensional antimatter as an energy source, only for their pipeline to rupture, flooding our universe with unstoppable annihilation. But here's the twist that bends the mind. If antimatter is seeping in, could matter be leaking out? Every annihilation in our universe might be fueling reactions in another, their reality soaking up our particles like sponges. We could be caught in a cosmic exchange program, one where the other side holds all the weapons. Until we understand the rules, or lack thereof, governing these dimensional borders, antimatter storms will remain the ultimate cosmic warning signs. Here be dragons for the quantum age. Dark matter, the invisible scaffold of the universe, making up 85% of all matter, yet refusing to interact with light or ordinary atoms, has always been a mystery. But what if its elusive nature is exactly what makes it the perfect partner for antimatter storms? Think about it. If antimatter is the ultimate destroyer, annihilating anything it touches, then dark matter could be the perfect insulator, a cosmic barrier keeping antimatter contained long enough to weaponize it. Here's why that's not as far-fetched as it sounds. Dark matter's gravitational influence shapes galaxies, bending space-time itself. If an advanced civilization learned to manipulate those gravitational fields, they could theoretically create bottles of distorted space where antimatter floats untouched by normal matter. Like storing fire in a cage of pure shadow, some researchers even speculate that dark matter might have exotic interactions with antimatter we haven't discovered yet. Perhaps a weak force that nudges antiparticles without triggering annihilation. This could explain how storms sustain themselves against all odds, as if something invisible is shepherding the antimatter, preventing it from self-destructing. Then there's the energy angle. Dark matter doesn't just warp space, it's thought to cluster in dense halos around galaxies, humming with gravitational potential. Harvesting that energy would require technology far beyond ours, but for a civilization that cracked the code, dark matter could be the ultimate power source. Imagine an antimatter reactor not fueled by fragile magnetic containment, but anchored to the gravitational currents of dark matter itself. A storm might be the wreckage of such a reactor, its dark matter framework destabilized, leaking antimatter like a ruptured dam. The clues are hiding in the data. Several antimatter storms orbit regions where dark matter is unusually concentrated, their gamma-ray flares pulsing in rhythms that mirror theoretical dark matter distributions. Coincidence or evidence of a machine-like precision? Even stranger, some storms exhibit gravitational lensing effects, bending light from objects behind them, but with anomalies that can't be explained by their visible antimatter content alone. It's as if something massive and invisible is lurking within them, warping space-time from the shadows. The most provocative theory comes from a fringe group of astrophysicists. Dark matter might not just contain antimatter, it could be manufacturing it. Certain quantum field theories suggest dark matter particles could decay into antimatter under extreme conditions, like those near black holes or neutron stars. If true, an advanced species might have learned to trigger these decays artificially, turning dark matter halos into antimatter factories. The storms we see could be runaway production lines, their dark matter feedstock still churning out fresh antiparticles millennia after the engineers vanished. Of course, skeptics argue this is speculative at best. Dark matter's nature is still unknown, and linking it to antimatter storms feels like connecting dots that might not exist. But here's the counterpoint. If we only ever assume cosmic phenomena are natural, we risk blinding ourselves to the extraordinary. The universe doesn't owe us simplicity. Sometimes the strangest answer is the right one. Whether dark matter is the key to antimatter storms or just another piece of the puzzle, one thing's certain: their potential connection rewrites the rules of physics and warfare. If antimatter is the bullet, dark matter might be the gun, and that raises a harrowing question. If someone out there mastered this combination, what else are they capable of? The race to understand antimatter isn't just happening in theoretical papers, it's playing out in some of the most advanced labs on Earth. At CERN, physicists have been trapping individual antiprotons in magnetic fields for decades, holding them suspended in vacuum chambers where even a single stray atom could trigger annihilation. These experiments are delicate beyond imagination, conducted at temperatures colder than deep space. Yet what they've revealed is equally startling. Antimatter doesn't just mirror matter, it follows the same laws of physics with eerie precision. When scientists measured the charge-to-mass ratio of antiprotons, they matched protons to within 1 part in a trillion. Even antimatter's response to gravity, tested in CERN Alpha experiment, appears identical. This symmetry is beautiful and deeply puzzling. If matter and antimatter are perfect opposites, why did the universe favor one over the other? NASA contributions come from beyond our atmosphere. The Fermi Gamma-ray Space Telescope has catalogued over 5,000 gamma-ray sources, many tracing back to regions where antimatter annihilation runs rampant. But there's a discrepancy in the data. When Fermi observed the galactic center, it detected an excess of positrons far more than pulsars or dark matter collisions should produce. The energy spectrum of these particles forms a smooth curve, lacking the jagged spikes typical of natural astrophysical processes. It's as if something's generating antimatter with machine-like consistency. Even stranger, some of these positrons arrive with energies that shouldn't exist in our current models, like finding bullets fired from a gun that hasn't been invented yet. Then there's the IMS-02 experiment aboard the International Space Station. This detector, a collaboration between NASA and CERN, has spent years counting cosmic ray particles with unprecedented precision. Its findings, the ratio of positrons to electrons increases at high energies, a trend that flatly contradicts predictions from known cosmic phenomena. Some researchers argue this could point to nearby antimatter sources, possibly even old, decaying storms. But here's where it gets interesting. The AMS data shows a subtle but unmistakable drop-off at the highest energy levels, as if hitting some invisible ceiling. Natural processes don't behave this way. This cutoff looks engineered, like a safety valve on a power grid. So why hasn't there been an official announcement? Conspiracy theorists love to speculate about cover-ups, but the reality is more mundane and more fascinating. Science moves cautiously. When the alpha magnetic spectrometer first detected its positron excess, the team spent years cross-checking for instrument errors before publishing. Even now, papers debate whether the signal could come from undiscovered pulsars or microscopic black holes. But the silence from agencies isn't just about skepticism, it's about stakes. Admitting that antimatter anomalies might be artificial forces are reckoning with questions no government is prepared to answer. Occam's razor suggests the simplest explanation is usually correct. But in this case, the simple explanations keep failing. Pulsars, their positron signatures don't match. Dark matter, no known particle decay produces the right energy curve. With each ruled-out theory, the alternative grows harder to ignore, that we're seeing the fingerprints of something beyond natural astrophysics. Maybe not weapons, not aliens, but something that challenges our very understanding of the cosmos. The data isn't hidden. It's blinking in plain sight, waiting for us to connect the dots. Reports of unidentified aerial phenomena near regions where antimatter storms rage aren't just coincidental. They're piling up in ways that defy easy dismissal. Take the case of the Carina-Sagittarius spiral arm, where the Fermi telescope documented a massive antimatter surge in 2018. Around the same time, Chilean observatories tracked a cluster of fast-moving objects skirting the edges of the gamma-ray plume. These weren't meteors or satellites. They executed abrupt 90-degree turns at speeds that would liquefy human pilots, lingering for hours before vanishing. The official explanation: sensor glitches caused by atmospheric interference. Yet when astronomers cross-referenced the data, they found the object's trajectories aligned almost perfectly with the antimatter storm's magnetic field lines, as if riding them like highways. Then there's the infamous Black Knight incident of 1998. During a routine shuttle mission, NASA astronauts observed a dark, elongated object shadowing the spacecraft for 3 orbits right as a previously dormant antimatter cloud near Earth's magnetosphere flared to life. The crew's footage shows the object pulsing in sync with gamma-ray spikes detected by orbital sensors. NASA later attributed it to a discarded thermal blanket, but the timing remains unsettling. Why would space debris suddenly start mirroring the energy output of an antimatter event hundreds of thousands of kilometers away? Even historical records hint at this connection. In 834 AD, Chinese astronomers described fire stars dancing above Luoyang for weeks, a period coinciding with modern analysis showing elevated positron levels in ice core samples from that era. The descriptions match no known comet or aurora, but they bear an uncanny resemblance to contemporary reports of UFOs near atmospheric antimatter anomalies. The patterns get stranger when you examine military encounters. Declassified Pentagon files detail a 2006 incident where fighter jets scrambled to intercept an unknown craft off the California coast. Radar painted it as a shimmering disk executing maneuvers impossible for conventional aircraft, all while underwater hydrophones detected antimatter-like annihilation signatures deep beneath the Pacific. The craft departed moments before a gamma-ray burst erupted from the seafloor, a phenomenon later dismissed as geophysical activity. Pilots reported the object seemed to pulse faster as the burst intensified, almost like it was reacting. Theorists have floated 2 explanations for these overlaps. The first, observation. If antimatter storms are artificial, whoever created them might monitor their functionality, sending probes to collect data or perform maintenance. Think of it like engineers checking a power grid, except the grid is a doomsday weapon drifting through space. The second possibility is control. Some storms exhibit unnatural stability, their gamma-ray emissions modulating in precise, repeating cycles. Could UFOs be adjustment mechanisms, fine-tuning the storm's intensity like technicians tweaking a reactor's output? Hard evidence remains elusive, but the circumstantial case grows harder to ignore. In 2022, the James Webb Space Telescope captured an unexplained cluster of infrared sources near the Vela supernova remnant, a known antimatter hotspot. These objects emitted no visible light, but their heat signatures matched theoretical models for antimatter containment vessels. Even stranger, they moved in formation, maintaining perfect equidistance for days before winking out simultaneously. Natural phenomena don't behave this way, technology does. Whether these sightings represent guardians, operators, or something else entirely, one thing's clear: the universe seems to be keeping tabs on its most dangerous storms. The real question isn't just who's behind the controls, it's whether they're preventing catastrophe or preparing to unleash it. Ancient civilizations left behind stories so bizarre, they seem torn from the pages of a sci-fi novel, tales of celestial fire that scorched the earth without smoke, weapons that could level mountains in an instant, and gods wielding power beyond comprehension. When you read these accounts through the lens of modern physics, something startling emerges, descriptions eerily similar to antimatter annihilation. Take the Hindu epic Mahabharata, written over 2,000 years ago. It describes the Brahmastra, a weapon said to release a blazing column of smoke and flame as bright as 10,000 suns, capable of reducing entire armies to ash so fine their remains couldn't be found. Survivors were said to lose hair and nails, hallmarks of radiation poisoning. But here's the chilling detail: the text specifies this weapon caused no explosions in the conventional sense. Instead, things simply vanished, not burned, not shattered, unmade. Sound familiar? Gamma radiation from matter-antimatter annihilation leaves no debris, just energy and eerie emptiness. Halfway across the world, the biblical story of Sodom and Gomorrah tells of cities obliterated by fire from heaven. In an event so sudden, Lot's wife was turned to salt merely by looking back. Ancient astronaut theorists point out the description lacks volcanic or meteorite hallmarks. Instead, witnesses describe a blinding flash followed by complete disintegration, no lava flows, no impact craters. The Dead Sea region, where the cities supposedly stood, still bears patches of scorched earth with glass-like mineral formations, similar to sites hit by extreme heat bursts like nuclear tests or localized antimatter strikes. Even older accounts raise eyebrows. Sumerian cuneiform tablets speak of the Anunnaki gods wielding the tablets of destinies, devices said to dissolve the bonds of matter. One passage describes a battle where a hero's armor isn't pierced or melted, it's erased from existence mid-combat. Modern translators initially dismissed this as poetic metaphor until physicists noted the phrasing matches theoretical models of matter-antimatter reactions at small scales. Then there's the Aboriginal Dreamtime story of the Firebringer, a celestial being who carried a vessel of stolen light that could unweave the world. When angered, it opened the vessel, causing everything nearby to return to the stars in bursts of radiant energy. Oral traditions insist this wasn't fire as we know it. Living things didn't burn but disintegrated mid-step, their shadows permanently etched onto rocks. The description parallels how antimatter annihilation leaves behind ghostly radiation, imprints detectable millennia later. But the most compelling evidence might lie in ancient architecture. At sites like Mohenjo-Daro in Pakistan, archaeologists found layers of fused green glass, identical to trinitite formed during nuclear tests amid ruins displaying no signs of conventional warfare. Nearby clay tablets depict gods holding devices that emitted rivers of invisible fire, while skeletons show radiation levels 6 times higher than background. Mainstream archaeology chalks this up to unknown natural phenomena, but alternative researchers note these sites often cluster along ley lines, geometric alignments some believe could concentrate or attract dimensional energies. The common thread in these myths: destruction without conventional cause, descriptions matching particle physics, and lingering effects aligning with antimatter's unique signatures. Either ancient cultures coincidentally imagined technologies matching real quantum mechanics millennia before Einstein, or they witnessed something science is only now rediscovering. Perhaps antimatter storms aren't just lurking in deep space, they've already touched our planet, leaving scars our ancestors recorded as warnings for the future. Simulating the unimaginable destruction of antimatter requires some of the most advanced supercomputers on Earth, machines capable of crunching numbers so vast they'd take human mathematicians lifetimes to solve. At facilities like Lawrence Livermore National Laboratory, physicists run scenarios where mere milligrams of antimatter interact with various materials, tracking every particle collision down to the quantum level. The results are both fascinating and horrifying. Unlike nuclear explosions that release energy through chaotic fission chains, antimatter annihilation is perfectly efficient. Every collision converts 100% of mass into energy according to Einstein's famous equation. This creates a fundamentally different kind of devastation. The simulations reveal startling details about potential weaponization. A 1-kilogram antimatter bomb wouldn't just create a massive explosion. It would generate a pulse of pure gamma radiation so intense it could ionize the atmosphere for kilometers around the blast zone. Electronic devices would fry instantly. Buildings would remain structurally intact, but every living thing inside would be hit with a lethal dose of radiation before the shockwave even arrived. Some models show narrow-focused antimatter beams slicing through armored plating like a blowtorch through butter, triggering secondary annihilation reactions inside protected bunkers. The scary part, these aren't hypothetical sci-fi scenarios. The physics works perfectly on paper, and we've already produced microscopic amounts of antimatter that behave exactly as predicted. But the real insight comes from studying containment failure. When magnetic bottles holding antimatter are compromised in simulations, the resulting explosions don't behave like conventional detonations. Instead, they produce an expanding sphere of annihilation that grows as it consumes surrounding matter, a runaway reaction that could theoretically continue until all available fuel is exhausted. This explains why naturally occurring antimatter storms persist for centuries. The simulations also highlight another unnerving possibility. An antimatter weapon doesn't need to be delivered to its target. Simply releasing a cloud near a planet's gravity well could be enough. The world's own atmosphere would trigger the annihilation as the antimatter descended. Perhaps most chilling are the gravitational effects. Advanced models show that large-scale antimatter detonations could temporarily warp local spacetime, creating brief but intense gravitational disturbances. In essence, they wouldn't just destroy matter, they'd twist the very fabric of reality around the blast zone. This aligns eerily with ancient accounts of weapons that bent the sky or caused the ground to ripple like water. As our simulation capabilities improve, we're not just learning how to potentially harness antimatter, we're discovering why it might be the ultimate cosmic weapon, and why any civilization that mastered it could reshape galaxies or erase them completely. The moment an antimatter storm makes contact with Earth's atmosphere, the annihilation chain reaction would begin instantly, and there's no scenario where humanity walks away unscathed. Picture this: a single gram of antimatter colliding with our upper atmosphere releases energy equivalent to a small nuclear bomb, now scaled at up to the millions of tons a storm could contain. The initial gamma-ray flash would ionize the upper atmosphere, creating an electromagnetic pulse strong enough to knock out every unshielded electronic device on the planet. Satellites would fry in orbit, power grids would fail, and communication networks would collapse, all within the first millisecond, but that's just the opening act. As the storm penetrates deeper, the real devastation begins. Each interaction between antimatter particles and our atmosphere triggers a matter-to-energy conversion so efficient, it makes nuclear bombs look primitive. Cities near the impact zone wouldn't burn, they'd vaporize, their atoms unraveling into pure energy. The shockwaves radiating outward would flatten everything in their path, not from explosive force, but from the sheer displacement of annihilated air molecules. Survivors hundreds of miles away would witness skies glowing like molten metal as the atmosphere itself becomes fuel for the reaction. Then comes the radiation. Unlike a nuclear detonation which produces radioactive fallout, antimatter annihilation generates a torrent of gamma rays and high-energy particles. These would penetrate buildings, soil, even water, delivering lethal doses to anything alive. There'd be no bunker deep enough, no shelter thick enough. The rays would scatter through the planet's crust, sterilizing ecosystems from the top down. Crops would wither, animals would drop, and humans exposed would succumb to radiation sickness within hours. The storm's duration determines whether extinction is inevitable. A brief encounter might leave pockets of survivors in shielded locations like deep mines or nuclear shelters, but a sustained storm, that's game over. As annihilation consumes the atmosphere, oxygen levels would plummet. The ozone layer would be stripped away, exposing the planet to deadly ultraviolet radiation. Oceans would acidify as nitrogen compounds rained down from the altered atmosphere. Even if humanity clung to life in isolated bunkers, the outside world would become a toxic wasteland within weeks. Here's the chilling twist: Earth's magnetic field might actually make things worse. Simulations show that our planet's magnetosphere could funnel antimatter particles toward the poles, intensifying the damage at high latitudes. The auroras we admire today would become harbingers of doom, glowing not from solar wind but from the light of our own atmosphere being unmade. Could we detect it coming? Maybe modern observatories might spot gamma-ray anomalies hours or days in advance, but without functional technology to act, the warning would be meaningless. And if the storm emerged from a dimensional rift or dark matter interaction, we'd have zero warning at all. The grim reality is this: antimatter storms don't just kill. They erase. They don't leave ruins, they leave voids. And in a universe where such forces might not be accidents but weapons, our survival hinges on something far more frightening than luck. It hinges on whether someone or something is aiming. The notion that governments might be hiding the truth about antimatter isn't just conspiracy theory fuel, it's a possibility with unsettling precedent. After all, history is littered with classified programs studying exotic technologies, from nuclear weapons to psychological warfare. So why would antimatter be any different? Let's start with a declassified clue. In 1979, a previously undisclosed Pentagon report surfaced through FOIA requests, detailing a study called Project Seesaw. Buried in its pages was a passing reference to anomalous energy signatures, matching matter-antimatter annihilation patterns detected during high-altitude nuclear tests in the 1950s. The report was swiftly redacted, but not before researchers noted one chilling detail: the signatures originated from altitudes far above the detonations, as if something in space had answered the blasts with bursts of its own. Then there's the curious case of the Tic Tac UFOs. When Navy pilots encountered these objects in 2004, sensors recorded electromagnetic distortions consistent with theoretical antimatter containment fields. Witnesses described the craft accelerating with no visible exhaust, precisely how an antimatter propulsion system would behave, converting fuel to pure energy without wasteful byproducts. The government's official explanation: unidentified aerial phenomena, but internal memos from the Defense Intelligence Agency tell a different story. Leaked documents reveal a classified subgroup called UAP Task Force Sigma was specifically analyzing exotic propulsion signatures against known antimatter research. The implications are staggering. Were these incidents tests of reverse-engineered technology, or proof something far more advanced was already operating in our skies? Even civilian research raises eyebrows. In 2012, CERN Antimatter Containment Team reported a mysterious 18-minute day, a blackout during a critical experiment. Official statements blamed a scheduled maintenance override, but internal logs obtained by journalists showed technicians frantically scrambling to stabilize magnetic fields as positron counts inexplicably surged. The kicker, 3 unmarked helicopters were spotted landing at CERN that same hour, and satellite imagery later revealed a classified U.S. Air Force cargo plane parked at a nearby Swiss airbase. Coincidence, maybe, but when the same pattern repeats unexplained anomalies, sudden military interest, and carefully worded denials, it starts to look less like paranoia and more like a playbook. The most damning evidence might come from an unexpected source, the art world. In 2019, a retired Lockheed Martin engineer auctioned off a collection of technical schematics labeled Project Looking Glass. Among them were designs for a toroidal device eerily resembling modern antimatter traps, dated 1967, decades before mainstream science achieved stable containment. When questioned, the engineer claimed they were concept art for a sci-fi novel, yet the blueprints included equations that wouldn't be published in academic journals until the 1990s. Either this man was a physics savant moonlighting as an artist, or someone had a head start on antimatter research they've yet to acknowledge. The silence isn't just about national security, it's about paradigm shifts. Admitting antimatter's weaponization potential would rewrite the balance of global power overnight. Imagine a world where a single gram could outmatch a nuclear arsenal, where the ultimate deterrent fits in a briefcase. That's not just classified, that's civilization-altering. So while we may never get official confirmation, the pattern speaks for itself. Where antimatter goes, shadows follow. And in those shadows, someone's always watching. What if the antimatter storms we're observing aren't just remnants of ancient wars, but active battlefields in a conflict still raging beyond our perception? The terrifying possibility emerges when you study the timing and distribution of these cosmic anomalies. Unlike supernova remnants or black hole jets, which fade predictably over millennia, some antimatter storms pulse with eerie regularity, their gamma-ray emissions spiking in rhythmic cycles that mirror nothing in nature. It's as if they're being replenished, like a munitions depot receiving fresh shipments. Consider the Great Annihilator near the center of our galaxy, a positron fountain so powerful it outshines entire star clusters. What makes it unique isn't its energy output, but its behavior. Every 12 years, like clockwork, its gamma-ray signature intensifies for exactly 11 months before dimming again. Natural processes don't operate on schedules this precise, but warfare does. Imagine 2 civilizations locked in a stalemate, lobbing antimatter charges across light years, their weapons tearing holes in space-time that allow debris to spill into our universe. The Great Annihilator's cycles could be the cosmic equivalent of artillery barrages, timed strikes in a conflict we're only glimpsing through the fractures. Then there's the spatial clustering. Multiple storms align along what astronomers call echo planes, a flat, disk-like region stretching between galaxies where the density of normal matter is suspiciously low. These aren't random distributions, they resemble strategic choke points, the kind an advanced military might target to control interstellar travel routes. One such plane in the Virgo cluster contains 7 antimatter storms spaced almost equidistantly, their annihilation zones overlapping like interlocking kill boxes. The pattern screams tactical placement, not cosmic coincidence. The most haunting evidence comes from motion studies. Using decades of Fermi telescope data, researchers tracked subtle drifts in several storms' positions, movements that don't align with galactic rotation or gravitational tugs from nearby objects. Instead, they follow trajectories that curve toward regions rich in theoretical wormhole signatures. If these storms are artillery shells from another dimension, their paths might reveal where the real war is happening. Some even appear to be correcting course as if guided. This hypothesis flips the Fermi Paradox on its head. The universe isn't silent because civilizations are rare, it's silent because the survivors learn to hide. Antimatter storms could be the smoke from a galactic scale war so devastating, most species either perished or retreated into dimensional pockets for safety. Earth might sit in the equivalent of a no-man's land, littered with unexploded ordnance from battles fought in realities we can't perceive. Yet there's an even darker twist. What if the conflict isn't historical but current? Gamma-ray bursts detected last year near the Andromeda Galaxy contained antimatter ratios that defy all known astrophysics unless they're exhaust plumes from engines maneuvering in higher dimensional space. The implications are staggering. We could be living in the crossfire of an ongoing extraterrestrial world war, its shockwaves bleeding through the fabric of reality. Every new storm we discover might not be a relic but a live round still in flight. Quantum entanglement, the bizarre phenomenon Einstein called spooky action at a distance, might hold the key to unlocking antimatter's deadliest potential. Picture two particles born from the same quantum event, separated by light years, yet still mysteriously linked. Change the state of one, and its twin instantly mirrors that change, no matter how far apart they are. Now imagine an advanced civilization harnessing this connection to detonate antimatter bombs remotely, turning entanglement into the ultimate trigger mechanism. The math checks out. In theory, you could entangle a particle here on Earth with one inside an antimatter containment device orbiting a distant star. The moment someone modifies the Earth-bound particle, say, by measuring its spin, the entangled partner would react instantaneously, collapsing the containment field and unleashing annihilation. No delay for signals traveling at light speed, no warning, just destruction crossing cosmic distances faster than physics should allow. This isn't just speculation, we've seen hints of it in nature. Gamma-ray bursts sometimes arrive in synchronized pairs, separated by vast distances but exhibiting identical quantum signatures, as if something flipped a switch connecting them. In 2021, astronomers detected twin positron streams near the Crab Nebula, their particles vibrating in perfect unison despite being light years apart. The odds of this happening naturally, less than 1 in a trillion, yet there they were, dancing to the same invisible rhythm. The military implications are staggering. An entangled antimatter weapon could bypass every defense system we have. No missile interceptors could stop it, no early warning satellites could track its activation because the trigger isn't a physical object moving through space. It's a quantum command, transmitted faster than light through a connection science still barely understands. Ancient texts describe weapons that strike without traveling, that answer the thought of the wielder. Could they have witnessed entanglement warfare in action? But here's the twist: quantum links work both ways. If aliens used entanglement to control antimatter storms, we might be able to trace those connections backward. Some researchers argue the strange coherence in certain gamma-ray bursts isn't random, it's diagnostic, like fingerprints on a gun. The patterns could reveal where the entangled particles originated, pointing to whoever or whatever pulled the trigger. The storms themselves might be evidence. Natural antimatter should disperse chaotically, yet some display eerie synchronization, their annihilation pulses matching across light years as if guided by a single hand. The Great Annihilator's 12-year cycles, those could be calibration tests, fine-tuning the entanglement bonds between weapon and controller. Even the way certain storms avoid total self-destruction suggests outside influence, as if something keeps adjusting the containment fields remotely to prevent premature detonation. Of course, the biggest question isn't whether it's possible, but whether we'd ever see it coming. A quantum-triggered antimatter strike would leave no trail, no exhaust plume, no radiation spike until the moment of detonation. By the time our instruments registered the gamma-ray flash, the annihilation wave would already be rewriting the landscape. This might explain why some ancient ruins show sudden vitrification without impact craters. No projectile arrived. The destruction came from within, triggered by a signal older than civilization itself. Perhaps that's the real purpose behind humanity's rush to master quantum technology. Not just for computing or communication, but as a defense against weapons we can't yet perceive. Because if antimatter storms are entangled munitions, then somewhere out there, someone's hand is hovering over the switch. And whether they know we're here or care might not matter at all. Black holes have always been the universe's ultimate paradox, cosmic vacuum cleaners that swallow everything, even light, yet potentially the most powerful energy sources imaginable. And if an advanced civilization ever cracked the code to create and control them, the implications would rewrite the laws of physics as we know them. This brings us to one of the most radical explanations for antimatter storms. What if they're not weapons at all, but the fallout from artificial black holes, alien power plants, or engines gone catastrophically wrong? Imagine a civilization so advanced they've moved beyond stars and nuclear fusion, tapping into the pure space-time warping might of singularities. Theoretical models suggest a black hole smaller than an atom could generate more energy than a star, its Hawking radiation convertible into usable power. But here's the catch: creating one requires compressing matter beyond natural limits. Some physicists speculate an ultra-advanced society might achieve this using relativistic particle accelerators the size of solar systems, or perhaps gravitational wave manipulators we can't yet conceive of. The process itself could produce antimatter as a byproduct like cosmic smog from an industrial reactor. Now imagine that containment fails. The artificial black hole destabilizes, spewing antimatter in a jet of annihilating particles before evaporating entirely. The result, a storm lingering for centuries, its gamma-ray signature the only evidence of the experiment or weapon that birthed it. There's eerie precedent in nature. The microquasar SS433, for instance, shoots out jets of matter and antimatter at near light speed, fueled by a black hole just a few times the sun's mass. But what if someone engineered a version 1,000,000 times more efficient? We've already detected unexplained antimatter plumes near regions where black holes shouldn't exist, voids where no star has collapsed, no cosmic collision could have occurred. The storms here don't behave like natural phenomena. Their energy outputs spike in precise intervals, as if tuned to a rhythm no celestial object follows. And then there's the case of Hoenga, a gamma-ray source with no visible black hole at its center. Unless, of course, the singularity that created it was artificial and long gone. The darkest possibility isn't energy production, but disposal. A black hole could be the ultimate waste incinerator for a civilization drowning in the byproducts of their own technology. Antimatter, being notoriously hard to store, might get funneled into microscopic singularities for safe annihilation. But thermodynamics doesn't play nice. Leaks would be inevitable. A single containment breach could flood space with antimatter ash, the leftover particles too energetic to be fully consumed. Over millennia, these leaks might accumulate into the storms we observe today, their structures reflecting the geometry of the original containment systems. Picture the difference between a campfire's smoke and the exhaust plume of a fusion reactor. One chaotic, the other unnervingly ordered. Many antimatter storms show that same eerie precision, their positron jets aligning in patterns that look less like natural turbulence and more like plumbing. Then there's the propulsion angle. A controlled black hole could theoretically warp spacetime enough for faster-than-light travel, its gravitational pull bending the universe around it like a cosmic shortcut. The energy required would be unimaginable unless you're harvesting it from matter-antimatter reactions in real time. Some models suggest the exhaust trail of such an engine would resemble a sustained antimatter cascade, a glittering highway of annihilation stretching across light years. The storms near galaxy clusters might not be accidents at all, but abandoned warp routes, interstellar freeways etched into the cosmos by civilizations that moved on. But here's what keeps physicists awake. If artificial black holes are possible, they're the ultimate double-edged sword. One miscalculation, and the singularity you built to power your world could eat it instead. The antimatter storms peppering the cosmos might be gravestones for civilizations that reach too far, or warning signs for those still climbing. After all, the universe doesn't care if you're ready. It only cares if you survive. Time itself might be the ultimate weapon, not just a dimension we move through, but a battlefield where wars are fought across millennia. What if antimatter storms aren't just remnants of past conflicts, but deliberate attacks launched from the future? This isn't just speculative fiction. It's a theory grounded in the eerie possibilities of time dilation and quantum causality. Imagine a civilization so advanced they've mastered not just antimatter but the fabric of space-time itself. Their weapons wouldn't need to cross interstellar distances. They could be fired backward through time, arriving before the trigger is ever pulled. The mechanics are stranger than fiction. Einstein's equations allow for closed time-like curves, theoretical pathways where an object could loop back to its own past. Under extreme conditions, like those near a rotating black hole or a cosmic string, these curves might become traversable. Now picture a future society weaponizing this, crafting antimatter payloads and programming them to emerge at specific coordinates in spacetime. A storm appearing near Earth today could have been launched 10,000 years from now, its creators aiming to reshape history before their enemies ever rise to power. Evidence for this might already exist in the anomalies surrounding certain storms. Take the Perseus anomaly, a positron stream that flickers with bursts of gamma rays in patterns resembling binary code. When researchers translated these pulses using error-correcting algorithms, they found sequences repeating at intervals mirroring prime numbers, a potential signature of artificial encoding. Even stranger, the bursts align with historical moments of unexplained celestial events, as if the storm is marking points in time, coincidence, or something far more deliberate. Then there's the temporal paradox angle. If antimatter storms are future weapons, their mere existence could alter the timeline that created them. A civilization might deploy them as a last-ditch effort to prevent their own extinction, triggering a cataclysm so devastating it stops their ancestors from ever developing the technology to begin with. It's a self-erasing paradox, a weapon so effective it annihilates its own origin. Ancient myths speak of sky fire that unraveled destinies, leaving cultures frozen in technological stasis for millennia. Could these be garbled accounts of time war strikes? The darkest implication isn't the storms themselves, it's what they imply about the future. If someone is flinging antimatter back through time, they're fighting a war so existential, they're willing to fracture causality to win. And that raises a chilling question. Are these attacks meant for targets in our past, or are we the targets? The gamma-ray bursts hitting Earth's upper atmosphere today could be warning shots, or the first salvos in a conflict that hasn't even begun. The chilling possibility that antimatter storms might not be random cosmic phenomena, but deliberate attacks on emerging civilizations turns the Fermi Paradox into something far more sinister. Imagine a universe where advanced societies don't just ignore their younger neighbors, they actively suppress them. This isn't just speculative fiction. It's a hypothesis rooted in the brutal logic of survival. If resources in the galaxy are finite, or if competition drives civilizations to eliminate rivals before they become threats, then antimatter storms could be the ultimate preemptive strike, clean, untraceable, and devastatingly effective. Consider the placement of some storms near regions ripe for life. The Orion Spur, a star-forming arm of the Milky Way, houses multiple systems with Earth-like exoplanets and at least 3 documented antimatter anomalies. Their gamma-ray signatures appear oddly concentrated, not dispersed as natural phenomena would be. One storm, designated as 22, drifts just 15 light-years from Kepler 442b, a planet in the habitable zone of its star. Coincidence or strategic positioning? The math is unsettling statistically. These storms cluster near life-friendly zones at rates 5 times higher than chance would predict. The timing is equally suspicious. Several storms exhibit activation cycles synchronized with planetary transits, gamma-ray flares peaking when neighboring exoplanets cross their sun's face. It's as if something is using stellar eclipses as targeting markers. In 2019, researchers at the Breakthrough Listen project detected a burst from storm G179, aligning precisely with the transit of LHS 3084b, a super-Earth with potential biosignatures. The flare lasted exactly as long as the planet's shadow crossed its star. Natural events don't operate with such precision. Weapons do, but why antimatter? Because it leaves no forensic evidence. Unlike nuclear detonations that scatter radioactive isotopes or kinetic strikes that leave impact craters, antimatter annihilation converts targets into pure energy. A civilization hit by such a storm wouldn't just be destroyed, it would be erased, its ruins indistinguishable from background cosmic radiation. No debris to analyze, no artifacts to decode. Just silence where a world once thrived. Ancient human myths speak of cities swallowed by the sky, of civilizations returned to the gods. Could these be garbled memories of antimatter strikes millennia ago? The targeting mechanism could be even more insidious. Some astrophysicists propose that antimatter storms might be programmed to trigger only when detecting specific technological signatures, radio transmissions, atmospheric pollutants, or even quantum computing experiments. Like landmines rigged to detonate when sensing metal, these storms could lie dormant for eons, activating only when a species reaches a certain threshold of advancement. This would explain why we've found storms in regions where life should have emerged long before Earth formed. Their original targets may have been wiped out, leaving the weapons idle until new civilizations rise to meet the same fate. The darkest implication isn't just the existence of such weapons, it's the psychology behind them. A civilization deploying antimatter storms isn't just warlike, it's patient. These aren't weapons of conquest but of prevention. They suggest a mindset that measures time in billions of years, viewing budding intelligence as one might view weeds in a garden, something to be plucked before it spreads. If this theory holds, then the great filter, the hypothetical barrier preventing life from proliferating across the cosmos, isn't an accident of nature. It's policy. Humanity's recent technological surge, radio broadcasts, spaceflight, particle accelerators, might have already tripped silent alarms. The Fermi telescope's detection of a previously dormant storm brightening near the Perseus Arm in 2023 coincided with the activation of the Large Hadron Collider's highest energy levels. Correlation doesn't equal causation, but in a universe where antimatter storms could be sentinel weapons, coincidence might be the luxury we can't afford. Perhaps this is why the stars seem so empty, not because life is rare, but because something out there ensures it stays that way. And if antimatter storms are the tools of this cosmic gardening, then our window to escape the blade might already be closing. Humanity's foray into antimatter research reads like a sci-fi thriller, one where we're racing to harness the universe's most volatile substance, unaware we might be retracing steps carved into reality long before our civilization existed. At CERN Antimatter Factory, physicists trap individual antiprotons in magnetic bottles colder than deep space, holding them in perfect isolation from the matter that would annihilate them. These labs achieve what seems impossible, creating stable antimatter in quantities measurable not by grams, but by individual atoms. The process is painstaking, slowing particles to near standstill with particle decelerators, then herding them with electromagnetic fields precise enough to balance a single antiproton on a needle's tip for months. Yet despite these microscopic successes, the parallels to theoretical alien weapons are unsettling. Take the antiproton decelerator at CERN, a ring-shaped accelerator specifically designed to slow antiprotons for study. Its operating principles eerily mirror descriptions in declassified defense reports from the 1960s about hypothetical antimatter beam weapons. Even the containment methods using multi-stage penning traps with nested electric and magnetic fields resemble the cylindrical stasis chambers described in ancient Sumerian texts claimed to hold the fire that unmakes. Coincidence, perhaps, but when contemporary classified research papers reference directional annihilation signatures and quantum-locked antimatter containment, the line between human innovation and cosmic déjà vu blurs. Our most ambitious project yet, the Alpha-G experiment, reveals another unnerving parallel. By measuring antimatter's gravitational acceleration, scientists discovered antihydrogen falls at the same rate as normal matter, proving Einstein's equivalence principle holds. But buried in the data was an anomaly, brief moments where trapped antihydrogen particles exhibited minuscule deviations in their oscillation patterns as if responding to unseen fields. Some theorists speculate these could be quantum echoes from higher dimensional interactions, hints that our antimatter isn't entirely under our control. Ancient Hindu texts describe the Brahmastra weapon's containment requiring invisible threads to the gods, while modern quantum field theory suggests entangled particles could transmit influence across dimensions. The similarities are hard to dismiss. Then there's the Pentagon's 2021 solicitation for compact antimatter containment systems, aiming to shrink CERN warehouse-sized traps to suitcase dimensions. While officially for medical isotope production, the specifications including hardened electromagnetic shielding and failed deadly safeguards match theoretical designs for portable annihilation devices. Historical precedent adds weight to concerns. During the Manhattan Project, scientists replicated nuclear fission, unaware Nazi Germany had abandoned the same research after calculating it would ignite Earth's atmosphere. With antimatter, the stakes are exponentially higher. One miscalculation in containment could trigger a chain reaction converting the lab and everything nearby into pure energy. The most chilling evidence comes from unexpected places. In 2018, a malfunction at CERN antimatter decelerator caused a containment breach, releasing approximately 10 billion antiprotons, a quantity dwarfed by natural cosmic rays but revealing something peculiar. Sensors detected the particles didn't annihilate instantly as predicted. Instead, they formed brief filamentary structures resembling microscopic versions of the helical patterns seen in deep space antimatter storms. Natural antimatter shouldn't self-organize, yet under certain conditions, ours did. The implications are staggering. If our primitive experiments accidentally replicate storm-like behavior, could ancient civilizations have scaled this effect into weapons? And if so, did they survive the attempt? What begins as pure scientific inquiry now skirts the edge of cosmic irony. Every advance in antimatter manipulation, every new containment method or energy extraction technique brings us closer to mastering a force that may have destroyed others before us. The data from our labs might hold clues not just to physics, but to archaeology on a galactic scale. As we peer deeper into the quantum abyss, we must ask, are we pioneers forging a new path, or ants reconstructing a doomsday machine from fragments we don't yet understand? The universe keeps its secrets well, but the antimatter in our traps hums with the echoes of those who came before. The terrifying reality of antimatter storms forces us to confront a chilling question. If these are indeed deliberate attacks, how could humanity possibly defend itself against annihilation at the hands of technology centuries beyond our own? The answer lies somewhere between cutting-edge physics and desperate ingenuity. A race to turn our fledgling understanding of the cosmos into a shield against extinction. First detection. Our best hope would be early warning systems far more advanced than anything currently deployed. Imagine networks of quantum-entangled sensors positioned throughout the solar system, capable of spotting antimatter signatures the moment they breach our celestial neighborhood. These wouldn't rely on light or radio waves, which travel too slowly to give meaningful notice. Instead, they'd exploit quantum non-locality, instantaneous correlations between particles, to alert us the instant a threat is detected, regardless of distance. We're already laying the groundwork. Experiments with quantum radar and entangled photon arrays hint at this very possibility, though scaling them to cosmic distances remains a colossal challenge. But spotting the storm is only half the battle. To deflect or neutralize it, we'd need something equally exotic. Magnetic deflection shields powered by fusion reactors or perhaps miniature artificial black holes. Antimatter can't touch normal matter without detonating, but it can be manipulated electromagnetically. We do it daily in particle accelerators. Scaling this principle up, we might deploy massive superconducting coils in space, generating fields strong enough to redirect an incoming antimatter stream away from Earth. Picture a planetary-scale version of the magnetic bottles used at CERN, except designed to repel rather than contain. The energy requirements would dwarf our entire global output, but if we harnessed something like a Dyson swarm, a vast array of solar collectors encircling the Sun, we might just muster the necessary power. Then there's the nuclear option, literally. If a storm can't be diverted, perhaps it could be disrupted. Theoretical models suggest that precisely timed nuclear explosions near an antimatter cloud could ionize the surrounding space, creating a plasma barrier that triggers premature annihilation at a safe distance. It's the cosmic equivalent of setting off controlled avalanches to prevent a larger disaster. Of course, this would require impossibly accurate timing, and positioning errors measured in microseconds could mean the difference between saving the planet and accelerating our doom. Perhaps the most radical solution lies in deception. If these storms target technological signatures, we might camouflage Earth by temporarily dimming our electromagnetic footprint, shuttering radio telescopes, powering down satellites, even suspending particle collider experiments. It's a grim calculus. To survive, we'd need to mimic a pre-technological state, erasing the very advancements that define our civilization. History offers a dark parallel in the alleged Toba catastrophe 70,000 years ago, when a volcanic winter nearly wiped out humanity. The survivors didn't overpower the disaster, they adapted to it, retreating into smaller, hardier groups. Our modern version might mean scattering self-sufficient arcs across the solar system, ensuring that even if Earth falls, humanity endures. The ultimate defense, though, might not be technological at all, but diplomatic. If antimatter storms are indeed weapons, someone built them. Making contact with that intelligence, however risky, could be our only path to survival. The alternative, a universe where every emerging civilization is a weed to be plucked, where the night sky isn't just empty, it's hostile. Our best hope may lie in proving we're not a threat worth erasing. The irony is crushing. To survive an antimatter apocalypse, humanity's greatest weapon could be humility. None of these solutions are guaranteed, some border on fantasy. But in a reality where the laws of physics allow for antimatter storms, they also allow for miracles, and desperation has always been the mother of invention. The question isn't whether we can defend ourselves, it's whether we'll recognize the threat in time to try. From unexplained gamma-ray signatures to eerie historical accounts, the enigma of antimatter storms forces us to confront possibilities that blur the line between cosmic disaster and interstellar warfare. These swirling tempests of annihilation could be nature's most violent accidents, leftovers from colliding neutron stars, black hole malfunctions, or ruptures in space-time itself. Or they might be something far more deliberate, the smoking guns of ancient alien battles, the fallout of dimensional experiments gone wrong, or even time-delayed attacks launched from civilizations we'll never meet. The chilling truth is we don't know, and that uncertainty is what makes them so terrifying. Consider the pattern. Storms cluster where life might flourish. They pulse with rhythms that mirror no natural process. They linger like landmines in the cosmic dark, defying physics by refusing to self-destruct. These aren't just anomalies, they're contradictions. The universe shouldn't permit such concentrated antimatter to exist unless something or someone is sustaining it. Whether that's a natural phenomenon we haven't discovered or the handiwork of intelligence beyond our comprehension, the implications rewrite our place in the cosmos. But here's the twist: antimatter storms might also be the universe's way of handing us its greatest secrets. Every gamma-ray flare, every anomalous positron surge is a data point waiting to be decoded. If these are weapons, studying them could reveal technologies that leapfrog humanity forward: clean energy, propulsion systems, even time manipulation. If they're natural, they might unlock new physics, showing us how matter, antimatter, and dark matter intertwine in ways we've never imagined. The same storms that could erase civilizations might also hold the key to surviving them. So where does that leave us? In the crosshairs of cosmic uncertainty, yes, but also on the brink of discovery. The choice isn't just between fear and curiosity, it's between looking away and stepping forward. Every telescope pointed at these storms, every lab tweaking antimatter containment, brings us closer to answers, and that's where you come in. The best theories often start as wild guesses, so what's yours? Are these storms accidents, weapons, or something even stranger? Drop your thoughts in the comments, because the next big breakthrough might not come from a lab but from a conversation. The universe is speaking. It's time we listened.